Hey guys, this is the 2.2 notes. Last section we focus on vertex form. This is going to be on standard form of quadratic functions. Now, in vertex form, it was easy to identify your vertex because you just find your h and your k. Right? Again, we want to find the vertex, and it's going to be our h and our k. But it's in standard form, which is f of x equals ax squared, right, ax squared plus bx plus c, right? Where your a is a coefficient of x squared, your b is a coefficient of x, and your c is your constant, okay? Now, right, what we want to do is figure out how we can find the x coordinate of the vertex, given it in standard form. Well, our x is our h, right, of our vertex, and how we do it is the formula h equals opposite of b over 2a. Okay, so you take your b, your coefficient of x, take the opposite of it. So if it's positive, make it negative. If it's negative, make it positive. And then divide it by 2 times your coefficient of x squared, which is a. Okay, so this is your formula to find h, right, or your x coordinate of the vertex. So important, you're going to use this a lot in this section. So opposite of b over 2a to find your x coordinate. Now, to find the y coordinate, of the vertex, which is our k, right, we're going to follow these steps. You're going to substitute in h. So whatever you find for h, right, you can always find your x coordinate. You're going to take that h, what you found, right, the x coordinate, and you're going to substitute in h for x in the function. Okay. And now when you do this, you're able to solve for f of x, which is your k. Okay, so you solve for f of x, which is equal to k, right? And this is your y coordinate. Of the vertex. Right, so, right, use the formula h equals opposite of b over 2a, and then whatever you get for h, substitute it in for x into your function, and then you can solve for f of x, which is your k or your y coordinate. Now it'll be easier once we see it in numbers, right? If you want, you can label your a, b, and c. Right, your a is technically 1 here. Your b is -6, and your c equals 10. Okay, so h equals opposite of b over 2a. So opposite of -6 over 2 times a, which is 1. So we get 6 over 2, which equals 3. Okay, so there's your h. Now we're going to substitute h in for x. So f of x equals, I'm going to substitute 3 in whenever I see an x. So 3 squared minus 6 times 3 plus 10. 3 squared is 9. -6 times 3 is -18. And then plus 10. And then when we combine them all together, we get 1, which is your k. Okay. So therefore, your vertex is h comma k. So it's 3 comma 1. And that's how we find our vertex. Okay, so we're going to need to use this in order to solve for are like graphing and things like that, because you need your vertex, your axis of symmetry to graph, and then you just need to find one point. And we'll go on with that stuff after this question. All right, here's the try it on your own. What I'm going to do is have you pause it if you're going through the notes through this video, and then I'm going to show you the answer and kind of go through the answer real quick. Okay, so hopefully you try this on your own. Here's the solution. All right, so B is -8, so opposite of B is 8. Right, over 2 times 1, because A is 1, so 8 over 2 equals 4. Then we take this 4, we substitute it in to for all the x's, and we get -11. Therefore, your vertex is 4, -11. All right. So the first example was to figure out how we do it. Now we need to find the vertex and use it to help us graph. Okay, so we're going to follow these steps in order to sketch a graph of this function in standard form. So the first step says find the vertex and the axis of symmetry. Right, we know our axis of symmetry is just our h. Okay, so h equals opposite of b over 2a. All right, so opposite of -4, because b is -4, over 2 times a, which is 1. So we get 4 over 2, which is 2. So axis of symmetry, x equals 2. All right. So we have h equal to 2. Now we need to substitute that into solve for our k. So our k is 2 squared minus 4 times 2 plus 8. So we get 4 minus 8 plus 8 equal to 4. So therefore our vertex here is going to be 2, 4. Okay, so we have a vertex and axis of symmetry. So let's plot our vertex. So 2, 4 is here. All right, that's our vertex. And then our axis of symmetry is x equals 2. The reason we draw this axis of symmetry is because, right, if we find one point other than our vertex, then we can just find the point reflected over that axis of symmetry, right? We don't even need to find, like, plug in and find another point, right? We just find the symmetric point on the other side of that axis of symmetry. Right? So one of the easier points to find when given in standard form is finding the y-intercept, right? That means x is 0, right? So that's when x is 0. So the y-intercept is f of x, and we substitute in 0 for all the x's. So 0 squared minus 4 times 0 plus 8. You're going to notice, right, obviously, whenever you substitute in 0 for x, it's going to cancel out. So your y-intercept is always that c, or that constant. So your y-intercept is y equals 8, right? So that is 0, 8. So we plot it, 0, 8. Right? And now we need to find the point. The next thing is find the point that's symmetric. So it's going to have the same y value, right? Same y value as the y-intercept, except it's going to be the and it's going to be the same distance from the axis of symmetry, just on the opposite side. So we can see 0, 8 is 2 to the left of the axis of symmetry. So our point symmetric to this is 2 to the right. And then we plot that point, right? So our point symmetric, right? So as a hint, right, it should be the same distance, right, from the axis of symmetry But on the opposite side, okay, right, and so that point is 4 comma 8, right? 0, 8 was 2 to the left, right, of our axis of symmetry, so we need to go 2 to the right to find the symmetric point of the of this, and that's 4 comma 8. And then the last step is just to sketch the graph. So it's a parabola going up. Doesn't have to be perfect as long as it goes through the 2 points that we found and starts at the vertex 2 comma 4. Okay, so that's how we're going to graph it, right? So it's pretty much like the first example where we find the vertex, right? That's a big thing. And then the next thing just added is really finding the y-intercept. Once you find the y-intercept, you can easily find the symmetric point to find the 2 points to plot and make this quadratic function graph. All right, so what I want you to do is try this on your own. So you can pause the video if you're going through the notes on the video, right? And then I'll show the solution and kind of go through the solution. So pause it now. All right, so here's the solution, right? We solve for h, right? Opposite of b over 2a, right? Opposite of 6 over 2 times 1, so we get 3. Substitute it into our function and solve for k, we get negative 10. So our vertex is 3, negative 10. We find our y-intercept. I didn't even substitute in 0 in because you know it's going to be that c or that constant, right? That's always your y-intercept given us in standard form. So we find that y-intercept, right? That y-intercept, its distance away from the axis of symmetry is 3 to the left. Therefore, our symmetric point will be 3 to the right, which is 6 comma negative 1. Okay, so I plotted those 2 points, then made my parabola. Okay. All right, the last example for this section is focusing on in standard form again, but using a real world example. Okay, so essentially we're going to solve the same way, right? And but we're going to have a question at the end that we need to answer. So it says a water balloon was thrown from a window. The height of the water balloon over time can be modeled by the function negative 16x squared plus 160x plus 50. What is the maximum height of the water balloon after it was thrown? Okay, so what we can do is first find the vertex. Okay, so we want to find the vertex of this function. So h equals opposite of b over 2a. All right. Our a here is negative 16, our b is 160, and our c is 50. Okay, so, right, knowing our c is 50, right, remember that's your y-intercept. So that's 1 point that we can plot. Okay, now let's find this. So opposite of b, so negative 160 over 2 times negative 16, so negative 160 over negative 32, which equals 5. So there's your h. Now your k, negative 16 times 5 squared plus 160 times 5 plus 50. So negative 16 times 25 plus 160 times 5 is 800 plus 50. So we get negative 400 plus 850, which equals 450. So our vertex is 5, 450. So let's plot that. So 10, 20, 30. So halfway in between would be 5. So here's our vertex, and it's 5, 450. All right, this is our vertex. Okay, now axis of symmetry, right, is this point right here, is x equals 5, right? X equals 5, right? And then we said our y-intercept, which I already plotted, was 0, 50. So let's find a symmetric point, would be 10, 50. Right, because it's 5 on the right side instead of 5 to the left. Same y, 10, 50. So let's make our parabola. As you can see, it starts at 50, right? You can't throw water balloon from like beyond 0 seconds, right? So it starts at 0, 50, okay? And then it's going to hit the ground somewhere over here, okay? But our question focuses on what is the maximum height of the water balloon thrown. So we're looking for the highest y value. Well, our highest y value comes from our vertex because this is a concave down parabola. So our highest y value, or our max, right, would be our y value at our vertex. So y value for vertex, because it's concave down. So our solution is max height is equal to 450 feet. Okay, because is it saying feet? All right, I don't think it actually says feet, so let's just say 450. So there's your max height. Okay. Right, and if you want to kind of pay attention to this, right, like I said, this was 0 seconds. So these are the number of seconds. And right, this is our height. Right, from 0 to whatever, right? So our max height was 450 because we had a concave down parabola, and our vertexes would be our highest y value, and our y value of the vertex is 450. All right, now what I want you to do is try these little extra practice problems where you're finding the vertex and the y-intercept of a quadratic function, because we know those are the two things we need to graph, right? So this kind of works with the first and second question. So try these, and then I'll show you guys the answers. So you can pause this, and I'll pull up the answers in a second. So here's the solutions. Right, for part A, we get negative 276 for a vertex, and our y-intercept 0, 40. Right, y-intercept is very easy to find. It's always at C. Right, so next one, H is 2, so vertex 2. K is 11, so vertex is 2, 11. Y-intercept 0, 7. Okay. Now, if you wanted to find a symmetric point, right, how far away is this y-intercept from the vertex? Right, it's 2 away. Right, so it's 2 to the right, so our symmetric point, right, would be 2 to the left, so it would be negative 440. Symmetric point here, right, our y-intercept is 2 to the left, so we need to go to the right of that axis of symmetry, which is 2, so it would be 4, 7. Okay, and that's the end of the notes.